Okay, we're going to look at an example from the textbook, example 13 on a for the applied parametric equations for modelling, and look at this figure skating example. So the motion of a figure skater relative to a fixed origin O at the time t minutes is modelled using the parametric equations: x is equal to 8 cos 20t, y equals 12 sine 10t minus pi over 3, t is greater than or equal to 0. I highly recommend for all these questions just pausing and having a go between each section so that you're actively engaging in the material. It means you're more likely to learn. So what's the first thing you should be thinking about and having a go at? Find the coordinates of the figure skater at the beginning of his motion. Pause and have a few seconds to think about it and what you would do. Try and do it as well. And what you hopefully have done is you thought, well, at the beginning of his motion, the time must be equal to 0 minutes, so I'm going to substitute 0 into both of these two equations. T equals 0 into x equals 8 cos 20t, and t equals 0 into y equals 12 sine 10t minus pi over 3. And if you chose to do that, you did the right thing, and you might have already spotted the mistake on here. It's asked for the coordinates of the figure skater, so hopefully you also put in coordinates 8, negative 6, root 3. Okay. Part B. Find the coordinates of the point where the figure skater intersects his own path. Pause and have a think about it, and then click play. Now I think this is quite a difficult problem, and it certainly would be extremely difficult if you weren't shown an accurate diagram of this problem, and I think it's a little bit unfair in the question to not bring your attention at least to this by at least saying a short sentence like an accurate description of the position of the skater is shown on this diagram. But we have got an accurate diagram, we can see it, there's marked axes on it, and importantly we can see from the diagram that the point where the figure skater crosses his own path is also the point where he's on the x-axis. And so if he's on the x-axis, what do we know? We know that y must be equal to 0. So what we're going to do is we're going to solve this by substituting 0 in as y into the y formula. And that's going to mean that our y is equal to 12 sine 10 times 0 minus pi over 3. Sorry, y is 0, is going to be equal to 12 sine 10t minus pi over 3. If we just have a look at a quick solution of that. Yeah. Our y is equal to 0, I can substitute 0 in as my y into the equation. You might want to have a go at solving this yourself. We get that 0 is equal to sine 10t minus pi over 3 by dividing through 12. If I made theta equal to 10t minus pi over 3, I would get 0 equals sine theta. Solve for theta, and theta would be equal to 0 pi 2 pi. Theta was equal to 10t minus pi over 3, so my 10t minus pi over 3 is going to be 0 pi 2 pi. And that gives you that your t value was 10 over 30 minutes, 4 pi over 30 minutes, 7 pi over 30 minutes, etc. So I hope that solution makes sense there. Leave that there for you. What we asked to do for part C of this problem. Well, for part C, just to bring back your attention to part B of this problem, we found what t is, but we were asked to find the coordinates of the point where the figure skater intersects his own path. So substituting any of those t values in fact, what we find it should always be the same x value, and if you substitute that x value in, you get negative 4. So well done if you got negative 4 and you remember to state it as a coordinate in your solution. Part C, find the coordinates of the point where where the path of the figure skater crosses the y-axis. Again, pause, have a think about it, how I go. And well done if you decided that if it's where it crosses the y-axis, I can see it happens at 4 points, and of course we know on the y-axis x is equal to 0, so it's similar to part B and arguably a little bit easier because it told you it's on the y-axis. So you're going to now be making your x equal to 0 and solving that, looking for those first 4 solutions. So if you've not already had a go at that, you might want to have a go now. And when you click play, we'll have a look at the answer. Right, so when x equals 0, we can solve this and get that t is pi over 2, 3 pi over 2, etc. Substituting those first 4 values in, and we get these 4 coordinates, which you should just have a quick cursory glance and check that matches with what you're expecting. And then we're on to the final bit of this problem. Determine how long it takes the figure skater to complete one complete figure of 8 motion. Right, one complete figure of 8 motion. This is the main reason why I chose to make a Desmos visualization of this whole problem. So if we go right back to the start for our figure skater going around in this ice rink, we've had the horizontal motion, or motion in the x-axis, described by this equation here. So x, we can see that it's periodically moving with this by this function 8 cos 20t, and our y, we can see, is moving periodically with this motion 12 sine 10t minus pi over 3. For part D, determine how long it takes the figure skater to complete one complete figure of 8 motion. Well, I think this is difficult to get your head around, so let's just try and peel away everything else that's going on here to begin with. Okay, and let's just think about what's happening in x. Well, a full return to motion in x, we can see how periodic this is. And actually we know that cos repeats every 2 pi. We know that cos repeats every 2 pi. So if we know the period for cos is every 2 pi, the period for cos 20t must be, if you like, a stretch by the factor 1/20th of cos t, so the period of that must be 1/20th of 2 pi. So in other words, it's going to be 2 pi over 20 or pi over 10, which is the period for this function. This is how often this repeats. Every pi over 10 it goes back. If we have a look at our y, again, sine, as this is a sine function, sine repeats every 2 pi as well. So sine of 10t, you could think of that as a stretching of your sine graph by a factor of 1/10. That's going to repeat every 2 pi over 10. So that's going to repeat every pi over 5. Every pi over 5, that's going to repeat there. So if we combine these and we consider when is it that these are all going to when is it going to be that the figure skater returns, or how often is it going to be that the figure skater returns to their own path? It's going to be, if we chose a point, perhaps if we chose the start point when time was equal to 0, right back to our start of our problem where I had our 8 negative 6 root 3, that's written as a decimal there. That start point we're going to return to not after the x has done a full cycle, but after the x and the y have done a full cycle. So we're effectively looking for the lowest common multiple of the period of these two functions. So, working through that, what we get is that as, and then we read this out again to just re-emphasize, as the period of the cos t is 2 pi, the period of the cos 20t is going to be that 2 pi over 20, stretched by a factor of the 20th. The period for your y is going to be 2 pi over 10, so pi over 5. So they both need to complete those full periods, so it must be that it's going to be the lowest common multiple of those two periods when they've both completed it, which is our 2 pi over 10. Okay, or pi over 5 minutes, which works out as 38 seconds. I think that part D is particularly difficult, but hopefully that made it slightly easier. Like I said, there's a link to that Desmos visualization of this problem, which perhaps if you're just thinking about and trying talking through to yourself about, you might make it a little bit easier to understand that last part of the question. I hope that helped.